Hello, my name is Greg. I would like to show you the first steps needed to develop the Grasshopper Tekla drawing link. And to make it more interesting, let's start with one of the issues which were created by our users. So I think that we could pick this one because this is related to the moving of existing drawing objects. So the user would like to change the location of marks, dimensions or texts. And I think that the texts are the most easy to follow up. So we want to create a new component for moving only texts. Of course, the final version will be able to move more different types of drawing objects, but let's start with something quite easy to get on it. So we will try to move texts and how it can be accomplished. So at first we need the source code, which can be downloaded from the GitHub, and we can always download it as a zip or connect from the Git. And in the Visual Studio, okay, so here we are in the Visual Studio. Let's start with creation of a new branch, starting from the main one. And let's name it like the features, moving text moving, whatever. Okay, let's start with a separate branch. And here, what do we have in the solution? So we have just one project, and it is divided into different namespaces. You will probably mainly work in the components, which is divided further like in the ribbon in the Grasshopper. So we have the annotations, attributes, etc., etc., etc. This project has different configurations. So depending on what type of the Tekla, what version of Tekla you are using, then you have to switch those configurations, and it will change the needed packages, so it will automatically reload to get the proper DLLs for the Tekla. The project is configured that after debugging, it will run the Rhino, and here it is. So if you have Rhino installed into the different location, then you have to change this CS-Proj. So what could be our anchor? What could be our starting point? And I think that we want to move some drawing object. So the most similar thing is the component for the rotating of the view. So if we try to find the component rotate view, then we will see that, okay, so we have something quite similar. And what is the basic structure of every component? So the component is divided into two different things. The first one is related to the input outputs, and the second one is the logic. So what exactly has to be done with those objects. And as you can see, every class which has the component suffix, it has two different classes inside. So we have the rotate view component and rotate view command. And those commands is a kind of framework written for this project, where you specify what are you expecting, what the user is allowed to provide. So here, user has to provide two different parameters, the view and some value for the rotation. And as a result, it will get the view after the operation. So here in the command class, we are only instructing the Grasshopper. Okay, so hey Grasshopper, I will accept the views as a first parameter, and those views they should have, this argument should have the name view and the description. And I want to return from that component only one parameter, and it should be the view, and with this name. So depending of your usage, then you can of course return some lists or tree, but for now I think that the single input, the only one item is enough for this purpose. So what you would like to get would be some kind of a component like move text, let's stick with that name. And I think that then the easiest way would be to just copy rotate view and paste it as a separate one and then modify it step by step. So what has to be modified after copying? What is enough to create the new component? So at first you have to provide some naming convention that, okay, so how this component will be visible in the Rhino. So you have to prepare some component information. But what is the most important is the GUID, is the identifier of those components, and those can be found. I think that the easiest way is to just go to the file version specific constants, where you have to provide the mapping between the name of the component and its GUID. It's the same approach as for the live link. So this long dictionary is evaluated during the startup just to register those components in the Grasshopper. And as I said, you will get some inputs, some outputs, but what is between? Between is this method, invoke command, which just gets the input values from here. So here we are creating some tuple with those parameters, and then we are performing some logic. And for task which involves moving some objects, you have to move them somehow, and then you have to return this modified object to the further components. So that is mainly all. I think that what could be interesting is just the way how Rhino is trying to find its DLLs, the Grasshopper. So here we have the directory, which has to be also provided in the Rhino as a developer settings something. Let's try it out. So now I just want to show you that, okay, so when the Grasshopper is initializing, then he's trying to find libraries, DLLs, extensions in some set of directories, and it is the Grasshopper developer settings, the Grasshopper folders, maybe, no, Grasshopper developer settings. Oh, I should be more prepared. Okay, so here it is. So if you don't want to output your components into the real AppData directory, then you have to add your local directory where you have placed your repo, and it will make the Rhino to load this data during the launch of the Grasshopper. So those are the basic steps. You need to get the repo from the GitHub, and here it is. Then you have to open it, figure out which Tekla version you would like to operate on. Be sure that your local DLLs coming from the Grasshopper Tekla drawing link are loaded in the Rhino when it's launched the Grasshopper, and then try to find out how to create the new component. And as I said, what is the most interesting is the GUID, which can be found in the version specific constants, but also you have to provide some naming convention. You can skip the bitmap with just commenting this line. And that's mainly all. The essence is happening here in the logic of your component. And as I said, I think that you should try just to move the text by some vector coming from the input. So it would be quite nice starting point just to get the feeling that, okay, so I have some outputs, outputs, there is some kind of a logic, and the question is how to move the text. But of course, you have to think about different ways how it can be accomplished. So if you will have more questions, just ask them. I will try to answer them. But for the start, I think that it's quite a solid way. So, okay, thanks for today, and let's keep in touch.